Just because you brought up the topic of, arrows, let's talk about DAGs.
Yeah.
Historically speaking, econometricians have never liked DAGs, but, epidemiologists and biostatisticians, they loved it, right?
Hmm.
There is also this, the famous debate on the internet. There's a blog post on, I think, written by Daniel Pearl, on which Guido Imbens has, commented on a series of things. I think the belief is that, sometimes DAX can be misused. And I totally agree with it. A lot of people misuse it. They just draw a DAX and just to create an impression that they are an expert in, causality. But just because you can draw a DAX doesn't mean that you have established causality. For me, it's a hypothesis generating mechanism. How do you see it?
Yeah, I think it helps, as you say, as a hypothesis generating mechanism. I think it's a valuable tool, and I understand why econometricians are wary of it. I mean, I'm not a historian, but what I understand from the
I
evolution
think
of
you're the best person because you transitioned from econometrician to
yeah,
bias. You have the best of both the worlds view. Yeah.
yeah. What I understand that happened in economics is that they were not using DAGs, but they were using structural models,
Mhm.
which eventually Pearl's framework ends up being just a set of structural equations that are encoded in the diagram. But so, what is a structural equation? It basically is you just postulate that an equation is causal, right? That the variables on the right hand side are causing changes in the outcome variable in the left hand side of your equation. But then they used a lot of that, and then well, it's convenient because you can use regression to estimate the parameters of these equations. And then in economics, there was a crisis, and there's a famous paper, and I mention it in a footnote in my book, um, where I don't remember exactly the quote, but it's something like nobody trusts your data analysis because it is heavily reliant on these structural equations. It is too complicated. And there was this crisis of confidence, and econometricians then the Imbens and Angrist and all these people, David Card, they started going away from these techniques and relying on quasi experiments or natural experiments.
Mhm.
And then this is what they call the credibility revolution. So they are a bit wary of these complex structural models, which in the end, Pearl's framework is a diagram that just encodes a structural model.
Mhm.
They are much more um, um, able to trust a designed quasi experiment where you have more control over what you do and you can validate your causal assumptions more precisely. And I have a penchant for that approach. I think it's more convincing when you design a quasi experiment in a way that allows you to be more confident about your assumptions than if you just take a data set, postulate a DAG, and call it a day, right? Because I think there is this misunderstanding that when you draw a DAG, you are assuming that everything is causal already. Like you are kind of putting in your causality in the DAG. And I think they both have their place, but I think in quasi experiments, a DAG doesn't really help you understand what are the assumptions you need to meet. It's hard to encode that in a DAG. But if you are just looking to understand, like, oh, what variables should I adjust for? A DAG is super useful. But the DAG doesn't tell you how do you estimate these parameters? What is the variance? How many degrees of freedom do you have on your estimation? Things like that that are important to statisticians. So I think it's important to understand different limitations of different techniques. And DAGs are so intuitive that I think they are a great teaching tool. I think they are a great hypothesis generation tool. I think they are great to understand what variables we should adjust for, given that the DAG, we assume it is true. But then you can go, okay, let's draw a few DAGs and see what happens and what were the conclusions we would have with different DAGs, things like that. I think the important thing is to not be dogmatic and understand that causality and detecting causal effects is difficult. You cannot just do it on a Sunday morning. You need to think about what you're doing and what is the process, what is the data. You need a lot of domain knowledge because the causal assumptions are not testable. I mean, you can test certain things, but you cannot, you have to always at the end judge, is my set of assumptions plausible or not? So you have to think and you have to know a lot and you have to work hard. It's not easy.